Good morning. This is Lenny Ravitz with your talk today. This is Lenny Ravitz with Astronomical Revelations. And today, unfortunately, because it's constantly in the news in some form or function, or on the internet, or on the radio, I have to talk about global warming / climate change, and more specifically, I'm linking it to overpopulation. And then from there, I'm linking it to a little bit of culture, unfortunate culture that we are experiencing in the United States and in many other developed countries in the world. That has to do with a certain gender's desire to have children. Okay, I will put it that way. I'm not saying, look, both genders have a genetic desire to have children, but this is a cultural thing that I have to talk about. So, let's just, again, and this is just a taste, okay? Because I cannot explain everything in the amount of time that this talk is going to take. So, just a taste, and we may do some more later on. So, global warming / climate change. All right? Yeah, there's always been a political debate about it. Let's put it to rest. The Earth's climate has always and will always be in a state of change. If you look back through all the geological epochs and eras, the climate's always getting hotter or colder, drier or wetter, windier or calmer. It's always in a state of flux. The latitude that the tree line comes down to and goes up to is always changing. These things you can find in the geological record. You can find in the atmospheric record, which one looks at core samples of ice from Antarctica and Greenland and other places, even the Andes Mountains and the Himalayas, okay? Ice samples from glaciers. That's the main way you can test historical atmospheres. They have atmospheric testers all over the world, placed in locations where there won't be confounding variables affecting climate. So they don't put these testers in, next to Cleveland, Ohio industrial district. Okay, they put them on places like in Hawaii on Mauna Loa, at the top of it, where the air is, you have Pacific Ocean for thousands of miles, and your sample is going to be accurate. Okay, so the world's climate is always in a state of flux. Let's go a little bit deeper, though, and I've touched on this before. The sun is our star. Okay, I'm not trying to insult anyone's intelligence here, but just the sun is our star. It's been burning for billions of years. We don't know exactly how many billion years it's been burning for, but we do know that it is gradually getting cooler. The sun is gradually getting cooler. That is a fact. There's no way that the sun could be getting warmer. It's using up its fuel. So as it uses up its fuel, just like if you have a bonfire, gradually over time the fuel gets used up and the temperature starts to go down. The heat that's being put out goes down. So the sun is in fact getting cooler. So that's input number one. Input number two is the Earth's core. The Earth's core, by the same token, is also getting cooler. And I suspect that the planet itself is probably a little bit smaller, but we'll save that for another time. So the Earth's core is getting cooler too because that nuclear reaction that's going on in the core, it's not fusion, by the way, which we can talk about at some other time. I'll tell you why fusion is not a real thing. But that core reaction is also losing its fuel. 4 billion years ago, when the Earth was very young and it had, we'll call it the maximum amount of fuel in the core, the number of volcanic eruptions going on Earth were immense. And the amount of heat and volcanic gases and magma and things like that were being pushed out of the core like a giant pressure cooker with all sorts of leaks was at its max. Now, it's at what we'll call its minimum -1. Okay? Because all those volcanic reactions from a super hot core have been going on for billions and billions of years and using up and losing that fuel. So that heat being transferred to the surface of the Earth today is much less than it was 4 billion years ago. So that's input number 2. And at this time, so you should already be thinking, wow, input number 1, sun, input number 2, Earth's core, both cooler. So really what we'd be at today, based on just those 2 inputs, would be in a state of global cooling. But of course, it's not that simple. Like I mentioned before with Venus, what happens, my theory and my hypothesis as well, that's in some ways been tested, but my theory is that indeed all of that, as that heat dissipates out of the core, it goes to the surface. Okay, you could call it step 2. It goes to the surface, and the surface actually warms up. So that latent warming happens as the core loses heat, and the heat is transferred to the surface and thus dissipates throughout. So if you didn't already think about that to begin with, that we're not just getting heat from the sun. Okay? So if that's a, wow, I didn't know that, and you're, let's say you're a rabid global warming fanatic, yeah, that's an example of when, before you start spouting off, you should probably check some things out and think about some things first. So yeah, heat is being transferred from the core to the surface and then dissipating into space or being reflected into space. The sun's heat being reflected from the Earth in some cases, like with ice and snow and water, not as much water, but ice and snow clouds being reflected out into space. Now, of course, we know, because we've heard this term so much in the last 30, 40 years, the greenhouse effect. The greenhouse effect, we could call it input number 3. Excuse me. Input number 3, the greenhouse effect. So what is that? You probably already know, but I'll just go over really quick. Basically, it's the contents of our atmosphere having an effect on how much heat is being held in to the surface of our Earth versus how much heat is dissipating into outer space. The greenhouse effect. Kind of like a greenhouse. You build a greenhouse with windows, the UV light comes in, it gets trapped as heat and absorbs, the temperature goes up in the greenhouse, and thus you have the greenhouse effect. So the contents of the composition of our atmosphere will have and does have an enormous effect on the way the greenhouse effect works on Earth. So like in a place like Mars, for example, where the atmosphere is incredibly thin, I should check on what the composition of Martian atmosphere